Okay, on question 13. Oops, bad looking 3. 71.72. So if we want to split this into so many degrees, so many minutes, and so many seconds, if we've got 71.72 degrees, we know that the first number has to be a 71. All I'm doing is taking the whole number of degrees and putting it there. What am I doing with this part right here, the 0.72? What do I do to figure out what goes over here? Yes, sir. Multiply it by 60 using my handy dandy calculator. That's what you printed off?
I don't know what this is.
I'm not sure either. Okay. I can try to print one off for you here. You're talking 4.2, right?
Yeah, but I want some handwriting.
Oh my goodness, gee whiz. All right, so what do I do with the second? Now that I've multiplied the 0.72 by 60, what do I do with this thing? What do I put in the next? What do I put in the next part right here?
43.
43 whole minutes. And then I take the 0.2, multiply it by 60, which gives me, if only we knew what 60 divided by 5 was. 12. Thank you very much. So that's what we do. Basically just 2 steps. Okay. What else? Anything in the entire assignment odds except for 37? 33. Great choice. All right. 2 concentric circles with different radii and they have the same angle theta. Oh, by the way, for those of you who don't know, this is theta. And that's how you spell or phonetically talk about the Greek letter theta, which we will be using a lot this semester. It's used for angle measurements. Okay, so they said that the arc length 1 is 9 and the arc length 2 is unknown. Okay, we don't know that part. We know that, oh no, I'm doing 30. I must be doing, oh no, I am right. Okay. And then we have a radius of 11, and then the bigger radius is 44. Not drawn to scale, folks. That's what they got away with in geometry class, right? They could draw anything they wanted and then just say not drawn to scale. Because there's no way that that radius is 4 times the length of that. I'm sorry, I didn't plan on that. Okay. So let's see here. I'm going to guess that we have to use the 9 and the 11 to find theta. So what unit of measurement would you like to use? Would you like to use degrees or radians? Degrees? Okay. All right, so that means the whole circle would be 360. And then we've got 2 times pi times a radius of 11 equals 9. Any reducing that you know will happen right away from there? Any reducing? $360 and 2. How many times does 2 go into 360? 180 times, right? All right, so what are we going to do to get theta by itself? You basically have a proportion here, folks. How do we handle proportions? We cross multiply, right? Because this is 9 over 1. Now, if you don't like thinking about the idea of cross multiplication, we can think about it a different way. We can multiply by the reciprocal of whatever that mess is. What is the reciprocal of that? 180 over 11 pi. Now, for those of you who are going to be doing this with a calculator, which I'm sure all of us will be because ain't nobody in the room know how to do that, I would suggest using parentheses around that 11 pi or you're going to get it wrong. Okay? So, 180 times 9 divided by parenthesis 11 pi. How many degrees are we talking about? How many degrees are we talking about here? 180 times 9 divided by 11 pi. Let's figure out how many degrees. How many degrees are we talking about? Let's go 46.9. Thank you very much. That's what we got from this mess. 46.9 degrees. Okay. So now we need to find the other arc. That one up there. All right, so now we've got 46.9 over 360 times 2 times pi times 44. Use your handy dandy machine to figure it out. What's coming? What'd you get?
147.34. That seems big. Try this again. 46.9 divided by 360. Hit the enter button. Times 2 times 5 is 44. Good. Oh, 36, I've heard a couple people say. That's true. It is 36. Wait a second. So if this radius was 11 and that radius was 44, and this is 9 and that's 36, why is that happening? Say it again. Why did it get bigger by the same exact number? What kind of relationship that you studied in? You studied it in pre-calc, you studied it in Algebra 1, you studied it in Algebra 2, you talked about it in geometry class. Right? We got something over 360 times 2 times pi times r.
What kind of function are we talking about here? I'll give you some choices. Linear, quadratic, cubic, square root, logarithmic, exponential. Which one of those are we talking about? Linear. How do we know? What's the exponent on r? 1. Start of the first. Which means that all the stuff in front of the r has to be slope, right? And we know that it's proportional. So if the radius is going to get multiplied by 4, so is the arc length. Anyway.
Anything else? Yep. Sorry. Sachs, and then I'll go to Miss Sani.
Sorry, I was gonna ask about 45.
45? Mm-hmm. 2012 Olympics gold medalist Mariana Pajon races on a BMX bike with 10-inch radius wheels when she is traveling at a speed of 24 feet per second. How many revolutions per minute are her wheels making? Okay, so we want to go to revolutions per minute. We definitely want to multiply this by 60 seconds over 1 minute. Why do we want to do that? We need it in minutes, so we got to get rid of the seconds. My radius of my wheel is in inches, so I can find the circumference as 2 times pi times 10. So my circumference is 20 pi. But that's in inches, right? So we need to convert to inches because this is in inches. 1 foot is equal to 12 inches. And we needed to set that fraction up that way so that the feet would cancel out. We've got 1 fraction left, and it has something to do with this thing up here. Remember, our goal is to have revolutions per minute. Right now, we're golden on the bottom with minutes. What does that last fraction have to be? We know that this is equal to 1 revolution right here. 1 revolution of the bike tire gives me that amount of distance. So what fraction do I need? Do I put the revolution on the top and the inches on the bottom, or do I put the inches on the top and the revolution on the bottom? Revolution on the top, because that's where we want it to end up, and inches on the bottom. So, oops, now I know my inches cancel out. So I'm left with revolutions per minute. So yes, you have to multiply 24 times 60 times 12 over 20 pi. I do suggest that if you want to get this correct and you're trying to type a bunch of stuff, that you use parentheses around that denominator, or it will end up being wrong. So that's what I would do to finish off that question. Revolutions per minute. Let's see here. 24 times 60 times 12 divided by parenthesis 20 pi. I ended up with 275 basically. 275 RPMs. That kind of help? Yep. Miss Sani, what was yours? 35. To the nearest inch, find the perimeter of a 10-inch sector cut from a circular disc of radius 11. Radius 11, 10 degrees. And we want to find the perimeter. So that's the arc length. Oh, wait a second. They're asking for the entire perimeter of that section? Oh, so we do have to find the arc length, but it's more complicated than that because then we have to add both of the 11s in. Okay, all right. First I was wondering if this was just a basic arc length question, but touch more difficult. Times 2 times pi times 11. Okay, this is going to be the arc length, but then we have to add 22 to get the overall perimeter because you want all 3 parts. That, and that. Boy, I did a horrible job of coloring that. Okay. Does that make sense that we found the arc length of the outside edge and then we add the 2 11s? Pretty sure that's what they're getting at there. I'm like, did I do that right? I got 23.9. I'm hoping that's what the answer sheet said. That makes sense because 10 degrees is pretty small, so that outside edge wouldn't be that big. Okay. Okay, let's move on to 4.2 notes.